So far, we introduced Zn, which was the set of equivalence classes with respect to the congruence relation. This was the relation. Two integers are in relation if they are congruent modulo n. So here n, this n, is a positive integer. These equivalence classes with respect to the congruent relation, congruent modulo n relation, are called congruence classes. The relation is an equivalence relation which determines a partition of the infinite set of integers into a finite set of classes. There are n classes. Z mod n is a finite set, a set of n elements. We also introduced operations of addition and multiplication on Z mod n. These were induced from addition and multiplication of integers. So, theorem 2.7 in the book roughly tells us that the operations on this set, which we've introduced, have all expected properties. The properties of operations of addition and multiplication on the set of integers. For example, we have that for any three congruence classes A, B, and C, A multiplied by B plus C is equal to A multiplied by B plus A multiplied by C. theorem lists specifically 10 properties and gives quite simple proofs of these properties. I will neither list them nor repeat the proofs from the book. They are simple, you can read them there. Or you can try to do these proofs on your own. Again, as soon as you understand the notation, this is nothing but using definition of these operations to prove the properties. Now, a word on notations. As you see, this is a little bit heavy and lengthy. Typically, elsewhere, they do not use these notations. This book, the textbook, uses these notations and alternated with usual notations which are used elsewhere. Namely, typically people skip brackets and skip circles. They write it as in the lightest possible form, as light as possible, as lightly as possible. That is easier to write, but less clear than notations with brackets and circles. So usually one skips brackets and circles. Now, that means that instead of writing, say, they write, for example, they write A as an element of Zn, meaning a class whose representative is A as an element of Zn. This is of course ambiguous. Here A means A in brackets, although what is written is merely an integer. In particular, they will write 3 times 9 is equal to 3 in the 6. Meaning, the meaning of that is the class which contains 3 times the class which contains 9 is equal to the class which contains 3 in the 6. This is indeed true because 3 times 9 is 27, and 27 is in the same congruence class as 3 because 27 is congruent to 3 mod 6. The difference to 1 to 4 is divisible by 6. So instead of writing that in this heavy way, they simply have in mind the 6 and write 3 times 9 is 3. one has to be careful with with all these abbreviations. For example, one cannot cancel. One cannot make cancellations. This is true in Z6. However, if I try to cancel 3 out, we get 9 equals 1, which is false in Z6. Because 9 is not congruent to 1 modulo 6. 8, the difference, is not divisible by 6. So this is true while this is already false in Z6. Of course, when you write it this way, you got to very clearly specify where it is in Z6. In Z5, this is already not true. This is true in Z6, but not in Z5, for example. With this abbreviations for notations, one can go even a step further. Moreover, it is convenient to use powers. For an integer k, a positive integer k, you can write a to the k. We still live in Z mod n, so this is same thing as the class to the k, which is same thing as a times a k times. And this is the same thing as a class of A multiplied by class of A, and so further. K times in Zn, Z mod n. So all of them assumed to have same meaning. We are doing calculations in Zn. This is not a statement. This is just about notations used elsewhere for arithmetics in Z mod n, for the modular arithmetics. Let me also address some subtlety which the book does not related to this notation. For a subtlety, for positive integers, A and B, the meaning, there are several interpretations, two interpretations for the product AB in Z mod n. What is AB as an element of Zn? First interpretation: is that AB is meant as the class of A multiplied by the class of B. A multiplication in Z mod n B. There is yet another interpretation, second interpretation, we still think about B as B in brackets as a class, while we think about A as an integer. In this way, we think that AB is B, the class of B plus the class of B, and so further, A times. Again, so class of B is an element of Z modulo n. We can add these elements and times. This is also an element of Z sub n. So here we think about A as a class and use the operation dot and circle in Z mod n. Same about B. We think about both of them as elements of the set Z mod n. This is a finite set, a set of n elements. Here we think about B still as an element of Z sub n, while we take A as an integer element of Z, and think about the multiplication as A times B plus B. B added to itself repeatedly and A times. Similarly to what we took here, A to the K, A was multiplied by itself repeatedly K times. So here K is as in integer. A is assumed to be an element of Z mod n. Fortunately, there is no ambiguity. In fact, this thing, B plus up to another B, A times, by the definition of addition in Z mod n, is same thing as the class of B plus up to B A times. And this Here b is already an integer. So b plus b plus b a times is ab, just by addition of, by the definition of multiplication of integers. What is a times b? This is b plus b plus b, a times. And this is the same thing as class A times class of B, by the definition of multiplication of congruence classes. So we get that this interpretation and this interpretation give us same thing. This one and this one are actually equal. In contrast, we cannot think here about k. We do a very similar thing, but we cannot think about this k as an element of Zn, not an element of Zn. So here k is really an integer, not a congruence class. Altogether, in general, for modular arithmetics, I will use both notations, so does the book. I will try to make it clearer. What do we have in mind? How do we interpret annotations? Typically, no ambiguity shows up. You must understand both and must be able to easily switch in between notations. You must clearly understand when do we have in mind congruence classes and when do we have in mind integers, and how to pass in between if possible. Alright, thank you for listening. We will continue with modular arithmetics in the next video.